Okay, my name is Nick Lee, and I'll be going through Lab 1 for ENME 351. So first I'll go through my pre-lab. For question 1, you can see here that I have a truth table that I created in Excel. That goes through the selector wire, A and B, all the different states that are possible, and then I chose to invert it. Take the AND with A and the not S, and then the AND of B and S, and then this cell or this column here is the final OR gate that gives you the output of all of these different inputs. So the highlighted ones in green are the outputs that are going to give me the on state, or well, my LED will be on later in the lab. Question 2 as to create a NOT and an OR gate in Circuit Lab. So here you can see my two different states for the NOT gate, 5 being on and then inverted to nearly 0, and then at 0 volts, V out gave you 5. Here you can see my AND gates, all 4 different states that are associated with an AND gate. So 5 5 0 5 0 0 and 5 0, and you can see my outputs here. And then we'll go down to the OR gate, which also has 4 different situations: 0 0 5 0 5 5 and 0 5, and you can see all my different outputs here correspond to the OR gate situation there. Question 3 required us to create a 2-to-1 multiplexer in Circuit Lab. So here I have all 3, a couple of situations based on the truth table there. So I did 0, 5, and 5. This is my B, my selector wire, and my A input. And you can see the outputs here. And then for question 4, we went over to Tinkercad. So here's my circuit, my virtual circuit for the lab 1. You can see my inverter and an OR gate. And right now, my circuit is in the 1 1 1 state. So if I start my simulation, you could see that the LED is going to turn on. And then I can go through a couple of different situations here where it might be off. If my selector wire is at 0 and my A wire is at 0, you'll see that the LED will be off. And then if I were to turn it back on again, I would choose my selector wire to be 1. Selector wire to be 1, my A to be 0, and my B to be 1, and that should turn my LED back on. And all of these different situations are based on the truth table from question 1 in the pre-lab. And so let's go back to question 5 here. We were required to create a 4-to-1 multiplexer, which included 3 2-to-1 multiplexers. So here you can see that I have my 1, 2, 3, 4, 5, 6 inputs for all 3 multiplexers, and then these LEDs are there in order to indicate a output of 1 such that the light is on. And that would be all for the virtual side of this lab. Okay, so here we have questions 1 and 2 for the in-lab portion for lab 1. My current state of the circuit is everything is on high state. So I'll go through a couple of the different situations as shown in the truth table here. So this one is 1 1 1 and the LED is on. If I were to take the selector wire and bring it to low, it's still going to be on. And if I were to take the selector wire and A and move it to low, you can see that the LED turns off. And the same would go for selector wire at high and both A and B at low, the light is off. And I'll go ahead and do one more on state. That'll be S at 1, B at 1, and A at 0. You can see that the light is still on there. All right, and now we have question 3 for the actual in-lab portion of lab 1. You can see that my light is blinking when the selector wire is on the high state, and then if I switch it to the low state, you can see that it blinks a little faster, and my code can be seen here. And I believe that is it for lab 1.